Hey, Nyakalo and Tebu, how are you all doing?
Good and you, sir.
Oh, I'm good too. Where is Tebu? Tebu is quiet. How are you, Tebu?
I'm good and how are you, sir?
Oh, she's now here. I'm good too, thanks. Thanks. At least you guys can hear me. Let me quickly share my screen. Where was it? Textbook? Textbook. Okay, here it is. Can you all see my screen that side?
Yes, sir. Yes, sir.
Okay, thank you, guys. Let me then quickly, we've got less to do today, so we'll just do the last touch-ups and then get finished with Euclidean geometry. So do you guys remember that I left out this problem last time we were together? Uh, this number B, exercise 4. Oh, you guys forgot?
Yes, sir. We remember.
Oh, yes. So I tried to look at it. This is how I concluded that I can, or you guys can approach it. What's happening? I want to zoom out a bit. Okay. Then the statement was saying diagonals AC and BD intersect at E of this quadrilateral we are having. And then another statement is saying ABCD is a rectangle with AC is 10 centimeters. This is AC, that is 10 centimeters. And we know that diagonals of a rectangle are just like those ones of a palm. Therefore, diagonals of a rectangle bisect each other. This will be 5, and that will be 5. Okay. And BC is 8 centimeters. If this is 8, that is 8. Opposite sides of a rectangle are equal. Okay. And then the 2, there we're given it as 20 centimeters. Okay. Calculate the following. Now, last time we said if that is 20, D1 is 20, therefore, okay, we found, is it D? No, B1 is 20 as well, reason being alternate angles, AD is parallel to BC, okay, and then B2 here will be 70, that's 90 as the angle of a rectangle, minus that other 20, therefore B2 will be 70, we found that. Okay, and D1 there as well is 90 minus that 20 is 70. D1 is 70. Okay. Now, last time after I got those ones, and then I got stuck. And then, is there anyone of you guys who can give it a try, or should I just continue? Are you
You can
guys still there?
continue, sir.
Oh, okay,
Yes, sir.
okay, then. Okay, guys, let me just continue. So I tried looking at it using some Euclidean geometric techniques, but I didn't win. I failed. And then I was like, no, let me just not limit myself with Euclidean geometry. Let me just think outside of the box, think of other techniques. And then I visited Euclidean trigonometry. I mean, I found some technique that, okay, when I look at part, this is a right angle triangle because that angle there is 90 degrees. So this blue triangle is a right angle triangle, and I've got this side here, which I'm going to make that side an adjacent of this triangle, this 8 centimeters here. Okay, we were given this information here, AC for this side, and then I'm going to say that is my hypotenuse is 10 centimeters. Okay, I now have adjacent, have hypotenuse. Then I go to trigonometry, this technique. So Toa, I believe you guys know this. Do you guys know this technique? Uh-huh. Are you guys still there?
Oh, yes, sir. Yes, sir.
Okay, I was asking if you guys do know this technique or you ever heard of this technique in trigonometry, SOHCAHTOA, sine for opposite to hypotenuse, cos for adjacent to hypotenuse, tan for opposite to adjacent.
Yes, sir. We've heard of it.
Oh, yes, that's what I'm going to do to find that angle there, this one in this triangle, because I'm having BC, and then in this blue triangle of mine here, I'm saying my BC is an adjacent and AC is an hypotenuse. So I'm going to use cos here for car. Therefore, I will have cos, that angle unknown, C2 is equal to adjacent. My adjacent is 8 centimeters all over hypotenuse. My hypotenuse is 10. Then I want that C to be subject of the formula. Therefore, C2 will be equal to inverse of cos, then 8 over 10. Then can you guys please just punch the calculator there if you have any in front of you to get the answer for this? Is there anyone of you guys who would take a calculator?
So I got 36,87.
You got
36,87 rounded off.
Oh, okay, 36, comma
87.
87. Oh, okay, 87. Okay, fine. 36, comma 87. Let's keep that in mind. Oh, that is C2, not C1. Then let's see. We found this angle as is 36.87.
Yes.
Oh, okay, thank you. 0.87. Then if we have that, we now can use this 90 degrees here minus the one that we are having, then we can get C1. Okay, again, you can just use this Z here to find that one as equal to this one and use 90 degrees minus that one that you are having to get this one. And then now you will be done with those ones at the corners. Now, let's come to this part. So, what's happening? Okay, now let's come to those E's. Oh, okay, no, I didn't read the question. There's no where we are required to find those ones at E. We are now required also find the sides AD here. Okay, AD is that one. That will be equal to this one that we said it's 8 centimeters. That one will also be 8 centimeters because opposite sides of a rectangle are equal. And then AE is this one. Okay, we said diagonals of a rectangle bisect each other. If this diagonal, just like we were given here, that AC is 10, therefore we divide that 10 by 2, we get AE as 5 centimeters. Then the last one is AB. AB is this side, okay? And then we were given this side and this side. Therefore, you can use Pythagoras theorem in this right angle triangle to find AE. Does it make sense to everyone, guys?
So can you repeat the one for AE again? I mean
Oh,
AB,
okay.
sorry.
For AB, okay. Okay. Did you understand that this triangle here is a right angle triangle?
Yes, sir.
Okay. And then we have this side here as 8 centimeters. We are given also AC here as 10 centimeters. Therefore, we just want this unknown. We can say maybe X or unknown A or unknown AB. Then you use Pythagoras theorem, AC, I'm sorry, as hypotenuse, AC squared is equal to AB, AB squared plus BC squared. Then what is AC? Is 10 squared is equal to AB is the one that we are looking for. AB squared plus BC is 8 centimeters. Therefore, that will give us 100. AB squared plus 64. Then that will give us 36 is equal to AB squared. Therefore, your AB will be 6 centimeters. Then you are done. Does it now make sense to everyone?
Yes, sir. Thank you.
Are you
Yes,
sure?
sir. Yes, sir.
Oh, okay, guys. Thank you. Then now let's quickly go back to midpoint theorem to remind ourselves as the last part of Euclidean geometry in grade 10. Where is it? Oh, okay. So just a minute of you guys, the midpoint theorem. So with midpoint theorem, we are saying if in this triangle here, in that triangle, you are given that AD here is equal to DB for the triangle, you are also given that. If you are given those conditions, then you can DE is parallel to that line, BC. Then that's that part.
Yes, sir.
Okay. That's the first part of the midpoint theorem. Okay, guys, just feel free to shout out if I'm moving too fast or you don't understand something. Just shout it out. I will minimize the pace or I will just re-explain whatever you didn't understand. So now let's come in triangle ABC, AD is equal to D given. Now, in this case, oh my guys, sorry. I think it's that kicked me out. My connection is not that good. Ah. Yeah, now. My apologies, my apology, guys. This network is keeping on kicking me out. Can you all hear me now?
Yes, sir.
Oh, okay, thank you. Okay, thank you, guys. I'm so sorry, guys, for that. Let me quickly take advantage of it while it's still back and finish off my work. Where's my book? Here is it. So, did you all guys understand what I was saying here?
Sir, I'm not sure if it's just me, but I couldn't really see or hear anything you were doing during the second triangle explanation. So if you could do that again, sir. So can you please do it again, sir?
Oh, okay,
Explain it
not a
again.
problem. Okay, not a problem. Before I can explain, I just want to ensure this. Can you hear me? That's right.
Yes, sir, I can.
Oh, okay, thank you. So I was saying in this other triangle, the second one, if you are given that AD here, this line AD is equal to this line DB, and then also you are given that this line DE is parallel to this line BC. You are not given anything about the lines in this side. You are not given anything. You're only given that AD is equal to DB. AD is equal to DB. And then you are also given that DE is parallel to BC. That's when you now can conclude by saying this line AE is equal to EC, and this line DE is half of BC. That's what I was saying about this other second triangle. Do you get that?
Yes, sir.
Okay. So guys, does every one of you understand midpoint theorem now?
Yes, sir.
Yes, sir.
Oh, okay. Thank you guys for the feedback. And then I've got this exercise here, number B, this one here, this one. And I want us all to give it a try, guys, and just have a little conversation about this one here. They're saying the triangle ABC, triangle ABC. This is the triangle they are saying, okay, ABC. And then AE is equal to EB. This line, sorry, okay, this line here, AE is equal to BE, okay, and EF is parallel to BC, okay. Midpoint theorem might apply, okay, I don't know, I will hear from you. And again, in triangle ACD, this is triangle ACD, okay. We are there given that FG is this one is parallel to CD. Now prove that AG is equal to GD. Is there any one of you guys who can just share some idea of how we can approach this question? Are you guys still there?
Yes, sir.
Oh, okay. Or are you maybe still thinking of how you can approach this problem or what's happening?
Yes, sir. We're still thinking about it.
Oh, okay, okay, it's fine then, not a problem. We can just have maybe 2 minutes thinking, then maybe at 8:27, I will show up and see what's happening. Oh, it's already 8:27. Are you guys winning that side? Are you guys winning?
No, sir.
Oh, okay, I understand, guys. But what is midpoint theorem saying? If in triangle ABC, if in that triangle ABC, AE is equal to EB and EF is parallel to BC. What is it saying? Doesn't it is say this one now will be equal to that?
Yes, sir, it does.
Yes. That AF will be equal to FC, then your reason is midpoint theorem. Okay. Now we are done with this triangle ABC. Now let's come to this triangle ACD. Now we are sure and we know that AF is equal to FC. Okay. In this triangle now, in this one, we know, I want to erase that. Okay. Now in this triangle ACD, we know that AF is equal to FC. And by those red lines there, I was highlighting this information that FG is parallel to CD. Okay, we are given that FG is parallel to CD, and we know that AF is equal to FC. So now using midpoint theorem, is AG not equal to GD?
It is, sir.
Yes, it is. Therefore, now you proved that AG is equal to GD. You are done just like that using midpoint theorem. Is there anyone who've got some question, guys? Does it make sense to everyone?
It makes sense.
Okay, then what about others? Does it make sense to you guys?
Yes, sir.
Are you sure?
Yes, sir.
Okay, guys, thank you. Then let's go to our last question of Euclidean geometry and the last question of tonight, because next time on our next lesson, we are going to be doing the new chapter. I want us guys now to look at this problem. This one here, here. Okay. They are saying in triangle PQR, this is PQR, that's triangle, that's bigger triangle. Okay. PQ is equal to PR. PQ, they are saying PQ, meaning maybe this is an isosceles triangle. PQ is equal to PR. That's what they are saying. And remember, an isosceles triangle is triangle that is like this. This is an isosceles triangle. Those sides are equal, and these angles will be equal as well. Reason behind that statement being angles opposite equal sides or the base of an isosceles triangle. Okay, so I will say this is an isosceles triangle because PQ is equal to PR. Okay, therefore this angle will be equal to that angle. Okay, now let's continue with the statement and STRE. STRE is this one here. They are saying that is a parallelogram. So we know that parallelogram is a quadrilateral of this shape. This is parallel to that. This is parallel to that. Okay. And this is equal to that. This is equal to that. And this side is equal to that side. This side is equal to that side. Okay. Those are the properties of a path. So let's come to this one and highlight these properties. Okay, this side is parallel to that one, and this one as well is parallel to this one. Okay, and then when it comes to angles, this angle will be equal to that angle, and this angle will be equal to that angle. Reason being, opposite angles of the palm are equal. Okay, and then now angle Q. We are given Q here as x. We are given Q here as x, and then we are given P there as something like, okay, 2Q, and Q is x, therefore that will be QX. And then this, we were given that this is an isosceles triangle. This here will therefore also be x using our analysis, reason being angles opposite equal side. Then now let's go to the question and see what it requires us to do. Calculate the sizes of the angles of STRE. STRE is this parallelogram. So we want all angles in this parallelogram. So is there any one of you guys who can share some idea of how we can do this problem of calculating the sizes of the angles of this STRE? Are you guys still with me in the room?
Sir. Yes, sir.
Yes. Oh, yes. Were you giving me the feedback that you are still in the room, or you wanted to ask something?
No, sir, I was giving you feedback.
Oh, okay. No, it's fine. Okay. I thought you wanted to say something. But okay, to save some time, guys, okay, we can do this. Okay, this we were given that is equal to this. Therefore, these angles will be equal. If this angle here, sorry, if this angle here is x, that angle will be x. Do you guys agree to this part?
Yes, sir.
Okay, thank you guys. So now we were given that this is a parallelogram. Let me maybe use the blue color. We were given that this is a parallelogram, and this one then will also be x. Do you guys agree to this part? That this angle here will be x if this angle here is x. Do you guys agree to that statement?
Yes, sir. Yes.
Okay, then what do you think is the reasoning behind that statement?
So opposite angles in a palm are equal.
Oh, yes, 100% correct. So now, can you guys try to help me on how we can find these angles that we are left with now? This one and this one. This one and this one. Excuse me. Can you just guys please help me with that? How do you now think we can find those angles? Are you guys still thinking?
Yes, sir.
Oh, okay, guys, let me not rush you guys and give you some time to think about it. Are you guys winning?
No, sir.
Okay. Let me guys ask you this question. Okay. Now I'm going to ask you. Okay. In this paragraph, we found that as x. We also found that as x. Okay. Now, do you guys agree or disagree when I say this angle here, this one here, will be 180 minus x? 180 degrees minus x. Do you guys agree or disagree?
I agree, sir.
What's the reason behind that statement of yours?
So co-interior angles are supplementary.
100% correct. Yes, I totally agree with you. And then now what's that angle? What will that angle be there? If this one here is 180 degrees minus x, oh, who is she now? Are you still here?
Yes, I'm still here.
Oh, okay. I was asking you, what will that end is 180 degrees minus x?
So I'm not
The hint.
sure.
Oh, that's a palm. That's a parallelogram. Won't it be 180 degrees minus x as well? Opposite angles of a palm are equal.
Yes, sir, it will be.
Oh, yes, absolutely. It will be yes. Then you are done with the question. You are done answering the question. You are done with whatever you are required to do. You are done with everything. Is there any one of you guys who still have got a question regarding what we did tonight or regarding Euclidean geometry, everything that we done? Because this is our last lesson geometry. On our next lesson, we will be doing different chapter. Is there anyone with some question?
No, sir.
No, sir.
Oh, okay. Are you guys sure?
Yes, sir.
Oh, okay, guys. If then you are all sure that you've got no question session when we will be doing this other new chapter.
Yes, sir.
For being with me tonight, I appreciate it a lot. I will see you on our next lesson. You all must have a good night.
You too, sir.
Oh, thank you, Nyapalo.